My name is Mohamed Sultan. I am the chair of the Geosciences department, and I'm also a professor there. And I have been there for over 10 years now. Came from SUNY Buffalo. And my research interests are in the general area of applications of remote sensing data sets with traditional data sets like geochemical, geophysical, and modeling to address a wide range of geological and environmental problems. So I'm interested in a number of applications or research interests, and this includes the, as I said, the application of remote sensing data sets to address a wide range of geological and environmental problems. I'm particularly interested in the use of remote sensing data sets in the general area of hydrogeology. And we use the traditional data sets that all researchers use in this respect, geochemistry, geophysics, and whatnot. But what is different about our research is that we combined observations extracted from these traditional data sources with space observations, specifically from a data set called GRACE. And GRACE is a joint mission between NASA and its German counterpart. It was launched in 2002. It has been going on. It's supposed to work for 5 years only. Now it's over 15 years and it's still going strong. And the nice thing about this data set is that for the first time, we're able, using this data set, to look at temporal, meaning changes with time, in the mass of the Earth over the entire, almost the entire surface of the Earth and its subsurface. And that is enabled with this GRACE data. And why is this important? Because actually the only thing, not the only thing, in 99% of the cases that has to do with the changes in the water mass that is contained in the area that I'm looking at. So if I'm a hydrogeologist, this is a great tool for me because I can look at watersheds and basins, water basins, and see if they are drying up or getting wetter. I can look at the subsurface and examine whether my aquifers, the water reservoirs, are actually losing mass, meaning are being depleted with time, or they are gaining mass. And all kinds of applications. If you put a dam, can measure how much water is impounded behind this dam. So it's a huge tool that we can use to our advantage in the general area of hydrogeology. So that's an area that I'm very interested in, and I'm being funded to do this kind of work, and I'll get back to it. Another area that I'm interested in is land deformation. So again, from remote sensing data sets, we can look at an area and we can say it is subsiding. For example, deltas all over the world are experiencing subsidence. How much is the subsidence? Where is it happening? What is causing the subsidence? Are areas of research interest and have important societal implications as well. For example, we've been funded by the National Science Foundation to look at the subsidence of the Nile Delta. This is the home of 50% of the Egyptian population. If this area subsides and the sea is rising, as we know, because of the climate change effects, how much of it and where is it going to happen that the sea is going to encroach and endanger these sectors of the populations? So being funded by this project ended a few months ago. We're funded by the Saudi Geological Survey to look at land deformation in the Red Sea Hills. Specifically, they are interested in knowing where the landslides are happening, which ones are more likely to be triggered by precipitation, and what is the likelihood of that happening in the next 5 or 10 years. And we can do this using what we call radar interferometry. It's a technique by which we can measure deviations in land deformation of up to millimeter scale per year and so on. So we can actually tell them what landslide or which side of the mountain is moving and moving by what rate, and. So this is a kind of a very nice application that we're pursuing in many places all over the world now. A third application that we're also interested in is aquatic remote sensing. Where are the algal blooms occurring? What triggers their occurrence? And can we predict when they are going to happen and where they're going to happen? were funded by the Kuwait Institute for Scientific Research. Project ended about a year ago to look at the distribution, assess the distribution of algal blooms in the Kuwait Bay and what triggers them, and can we develop an early warning system for them that tells them, when and where are they going to happen. So for the past 8 years, my research team has been on the NASA Science Grace mission, and we are very happy to be on this team. It provides us access to data and provides us basically input on how the Grace mission and Grace data sets are going to be distributed, are going to be used for, and we'd like to believe that our group, where we have very talented people on the NASA Grace mission, we'd like to believe that our group is the one group that is actually geologically oriented, and as attested by the fact that our group has the only publication in the magazine Geology, in the magazine Earth Science Reviews, and now we've just recently, yesterday, got an article accepted in GSA Bulletin. These are the leading 3 geological magazines in the geological community, and only our group has an article in these magazines. We've just learned also a few weeks ago that we're going to continue to be on this team at least for another year, so that's encouraging as well. I want to add something about the interdisciplinary nature. Nobody can do anything alone, basically. And the integration of these sciences and input from various disciplines is very important if we want to address these complex geological and environmental problems. We have to address it with teamwork, and that's why we bring together researchers from within Western and from outside Western to help us out and provide contributions to relevant disciplines that we need to have on board. So we have, as we speak now, we have collaborations with University of Colorado, University of Delaware, Oregon National Labs, University of Georgia, and Middle Tennessee University. So that's also something of the strengths of this group. We'd like to believe that.